Located near Manhattan, Kansas, Tuttle Creek Lake plays an important role in the management of critical water resources in the region. Designed, built, and managed by the U.S. Army Corps of Engineers as a key component of its flood control efforts, the massive reservoir provides flood control, water supply, and recreation to over 1 million people and supports navigation to portions of the Missouri River network. However, sediment has accumulated during its more than 60 years of operation, reducing the lake's capacity and its flood control effectiveness.
Lakes around the world are filling in with sediment. I mean, to one degree or another, every single lake is filling in. And if we don't do something intentional and something significant, the future is that we don't have lakes. We just have a lot of muddy ponds without water storage.
Its long-term sort of viability and sustainability is really important for the continued growth and development of that portion of Kansas. But this is a problem across the Army Corps. We have over 419 reservoirs with water management plans, and many of them are approaching their expected lifespan due to sedimentation.
While Tuttle Creek Lake's primary purpose is flood control, it also supplies 40% of the drinking water for the state of Kansas. By 2049, it is estimated that Tuttle Creek will be 75% full of sediment, leaving just a quarter of its original storage capacity. To help restore capacity, the Kansas City District partnered with the U.S. Army Engineer Research and Development Center to study how an existing dredging technology primarily used in Europe could be used in a new and innovative way.
One of the main ideas was water injection dredging. But water injection dredging had never really been attempted before in reservoir environments. So ultimately, over the course of the research we've done, we're trying to demonstrate that it can be successfully implemented to mitigate sedimentation in reservoirs where it can be removed from the reservoir through the dam.
Since 2019, several of ERDC's research laboratories have studied every angle of this dredging method, from the amount of water and energy needed, to how the sediment will travel through the dam inlets, to how far the sediment will potentially travel downstream.
With water injection dredging, you are pumping clear water only tens of feet down to the reservoir bed. And so just right off the bat, there's just a lot less energy involved. And then rather than disposing of the sediment, you're recharging the sediment to the channel downstream just by passing it down. So it could potentially be much, much less expensive than sort of traditional dredging technologies. And with an issue as big as reservoir sediment, there's so much sediment to be managed that we need to get the cost down.
The requirements generally are that the material to be dredged needs to be very fine, silts and clays, capable of being suspended and staying in suspension for quite a long time so that it can transport some horizontal distance. The other requirement is that you need some way to remove the material. So Tuttle Creek Reservoir is somewhat unique in that the dam has near bottom outlet in a discharge so that the material can actually be bypassed out of the system. On the dredging side, the challenge is how to remove the material. Reservoirs are typically in mountainous regions, very hilly regions, with not very many receiving areas, material areas where a traditional dredge could take it out of the reservoir via pipeline and deposit it into like a disposal facility. That is also a very difficult sort of engineering challenge, removing that material and lifting it above the adjacent hills and mountain ranges to get it to that place.
The teams from ERDC and the Kansas City District, along with stakeholders in Kansas, expect the upcoming full-scale demonstration of water injection dredging at Tuttle Creek to validate the years of research and testing invested in this project.